Hi everyone and welcome to this new video. Now in this video I want to continue my BSCP guide, which is aimed at those preparing for the BSCP certification, and in this video specifically we will talk about OAuth, and so we will showcase some labs taken from the Portswigger Academy related to OAuth. Now I hope the video is interesting, I hope you get something out of it. If you want to support my work, there's a Patreon link in the description, and also if you're interested in web security, if you're interested in learning how to perform a penetration test over a vulnerable web application, I've released a course that shows you exactly that. We're talking about 17 hours of content. It is currently available on Udemy, and there's going to be a link in the description down below. So thank you very much and enjoy the video. Now let's talk about OAuth. Now OAuth stands for Open Authorization, and it is a standard that implements access delegation. Now basically what's the idea? Well, the idea is that it allows one application, which is known as the client, to access data like resources or to perform actions on behalf of a user in another application, the resource server, without having the user to share their password. So consider this setup. We are a given user, and let's say that we have like a Google Calendar application. Google Calendar. Technically, what we can do is we can authenticate to our Google account and we can mess up with the calendar, right? We can add new events, we can modify the existing ones, we can interact it with this application normally. Now, let's say however that I introduce a third component, a to-do app, a to-do application. And let's say that this application wants to be integrated with Google Calendar. So what's the idea? Well, this application shouldn't ask the user Google password, right? Because that's just dangerous to do. If the app gets compromised, the user lost his Google password, which is a critical asset to have. So instead, what we do is we use OAuth in order to allow this to-do app to perform specific actions and to read specific data from the Google Calendar, and this goes through the user permission. Like the thing is that the user allows this application to access specific elements of Google Calendar, and so the app can do that. So basically that's why it is implemented. It makes sense to have. Now, it is, by the way, it is officially defined in RFC 6749. You can find the RFC right here. Let's go here. And this is the data tract. The OAuth 2.0 authorization framework. The OAuth 2.0 authorization framework enables a third-party application to obtain limited access to an HTTP service, either on behalf of a resource owned by orchestrating an approval interaction between the resource owner and the HTTP service, or by allowing the third-party application to obtain access on its own behalf. So basically that is the idea, and this replaces the OAuth 1.0 protocol. So to understand OAuth, it is useful to review the components, the elements that are typically found in an OAuth interaction. And these are the following one. So we find the resource owner, which typically it is the client. So this is the person or entity who owns the data or resource. This could be you, for example, when logging into an app using your Google account. The resource owner grants permission to access the data. So you are the person who says, okay, you can access this data. Then we find the client, which is the application requesting access. So this could be, for example, a to-do list application that wants to access the Google Calendar data. And the client requests authorization and uses tokens to access the resources. Then we find the authorization server, which is the server that will authenticate the user and issue tokens. And this could be Google server, specifically Google OAuth server. Now the authorization server has different like jobs to do, has different responsibilities. He has to verify the user identity. He has to obtain the user consent for the specific data share. So basically what's going to happen is that the client will need the Google Calendar data. So they request it to the resource owner. The resource owner grants this authorization, and this has to go through the authorization server. So basically, at some point, the resource owner will interact with the authorization server here. And if the credentials are correct, they basically get an access token. So The authorization server verifies the user identity, gets user consent, and issues access and refresh tokens to the client. And then finally we find the resource server, which is the one that contains the user data, and this is protected by APIs that you need to have proper access tokens. That is, you need to have gone through the authorization server, otherwise you do not access the resource server. So basically that is the idea. Now, why do we need tokens? Well, in OAuth, tokens act as digital keys to let the client app access the resources on behalf of a user. And there are two main types of tokens in OAuth. There is the access token, which is a short-lived token that the client uses to access protected resources. And there's also the refresh tokens, which can be used to obtain new access tokens. So the access token is short-lived, the refresh token is it has a much longer duration, typically. And of course, the access tokens contains the informations that are required by the resource server to authorize the request. Because remember, here we are talking about authorization. That is, we want to know if a certain token is able to access a certain piece of data. So basically, that is the idea. Now, there's a difference between OAuth and OpenID Connect, or OIDC. Now, the purpose of OAuth is mainly authorization. That is, it is used to allow apps to act on behalf of a user in order to access resources. This means that it doesn't really handle authentication. Authentication is instead implemented by the OIDC, so OpenID Connect, which is a layer built on top of OAuth, and its focus is to add authentication capabilities. For example, this is what you typically find when you do sign up with Facebook, sign up with Google. So you obtain a full account, a full user session through your Google account. So with OAuth, we can handle who can access what. This is authorization. With OIDC, we can handle who is accessing the data. And this, of course, is authentication. Now, in these labs, we're actually going to authenticate with OAuth. So basically, we're going to use OAuth as an authentication mechanism, so it is not just authorization. Now, there are different OAuth flows, so there are different ways in which this delegation of access control can be implemented. For example, there's authorization-based, authorization code with the PKC, client credential flow, implicit flow, resource owner password credential. Some of these flows are deprecated, meaning that they are insecure because they expose user credentials, while some other are secure. Now, it is not the objective of this video to go through the detail of these things, because now we will start to analyze these different labs, and so we will talk about potential vulnerabilities in OAuth flows using these laboratories. So to get started, we are in the all topics section of the Pulsewigger Web Academy, and we go down, and we go to Advanced Topics or OAuth Authentication. We click here, we go to View All OAuth Authentication Labs. Oh, and by the way, here it also talks about OpenID Connect. So, OAuth was not initially designed with authentication in mind. It was intended to be a means of delegating authorization, and so they implemented OpenID Connect, basically. And so here they talk about OpenID Connect, but let's go into View All OAuth Authentication Labs. So here, let's go through the first lab, OAuth Bypass here, and let's start it. So what's the objective of this lab? Well, we can log in with the credential of winner, but we want to be able to log in with the Carlos account. So we have to find some means to bypass authentication and get inside Carlos account, even though we only have the credential for the winner account. So here I've spawned it up. I'm gonna put it into the browser here. So here I have the history. So what we notice here is that if you go into my account, we are now redirecting you to log in with social media. So at this point we see this OAuth login. We just do winner Peter, sign in. We sign in. And look at this, it says authorize. We like to blog, which is our client application, is requesting access to profile and email. So we are in the previous discussion, in this discussion here, basically, we are the resource owner, this is the client application, and the authorization server is asking for our approval. We like to blog is the client application, and the client application wants my profile and email. I'm gonna say continue. And so here I get inside the account of winner. Now, however, I want to get inside the account of Carlos. So how do I do that? Well, at this point, we can review what happens in terms of HTTP requests and responses, right? So let's focus on this. So what do we have here? let's go into, so we go into my account. Here we find a redirect to login. Actually, let me make the font a little bit bigger, I would say, so that it's a little bit more clear what's going on here. Okay, it's good. So we start by going to my account. Here, redirect is triggered to social login. To social login, here we get 200, and this is the HTML. Without redirecting, this thing, which contains this with OAuth. Now at this point, we are interacting with a different server. Now notice this. From social login, which the host is 0AF, the auth call here is made to OAuth and dash 0A6. So here we are talking with the OAuth server. So we are talking with the other component. Now, how does it start? So look at this. Here we have a client ID, which identifies the client application that started this flow. We have a redirect URI, which says after the flow is done, go to this endpoint. We want the token, we have a nonce, and we have a scope. So what we want basically. And here it's gonna say found interaction slash. So at this point we have the OAuth flow. So we found this interaction. Here if you render this page is the login page here. Then here we put our credential, look at this post. Here we are authenticating, and notice this thing, the credentials are not sent to the main website, they are only sent to the OAuth server. This is why we're talking about delegation, because we're not giving the credential to the application, we're not giving the credential to the client, but only to the authorization server. Okay, so here we give the credential, and by the way, here it says found. So here we're getting an auth something here, redirecting to interaction. At this point, what we have here is going to ask for our consent. Here I'm going to say post confirm, just a post confirm. Here is going to say out like this. And finally here, what do we have? We go back, look at this, we go back to the normal application. And here we have a so-called access token. So access token equal this thing, expires in profile email. So we do that basically. And then we do the get to out callback here, and then we do post authenticate. So post authenticate, here we have email, winner, and token. Now this token was found within this last, not this one, but after the confirm here, I believe. Yeah, look at this. After we've confirmed the application, like I'm gonna remove my webcam, the application emitted this redirect, right, to go back to the original website, and specifically with the OAuth callback. The OAuth callback contains JavaScript which will use the access token that we just obtained to authenticate with the application. So at the end of the day, we found this authenticate endpoint. Here we are not putting user credential, by the way, but we are putting the this token. This is actually called the authorization code, and it is used to signal that like this authorization code can be used by the client application in order to obtain the access tokens that are then required to actually obtain the data itself. So how do we deal with this? Well, a typical test that we can do is we can check if we can reuse the same token but with different credential. So we want to change the credential. Now typically these tokens should be usable only once, but let's try to use it with Carlos. So let's try to use it with Carlos email and Carlos data. Let's hit send. Notice it says found and it gives us a session cookie. Now, interesting enough, if we put the session cookie in the browser, here, we are changing this session cookie with the Carlos one. And if I refresh the application here, notice that in my account, I am Carlos now. So what happened? Well, the flow was not correctly implemented, and basically it can be hijacked at the last step. Now the last step is when you obtain this authorization code from the OAuth server. Now remember, let's look at all these requests. We basically have the initial request that triggers, so let me see here if I can just see this. We have the initial request that triggers the OAuth flow sent to the OAuth server, and here we have this OAuth callback. This means when you're done with this processing, go back to this endpoint with the data required for the application to retrieve the access tokens. Then, here we put our credential, here we say confirm, and at that point, we get this found from the OAuth server. Now in this found, you can see the redirect to the original server, the client application, with this access token. And then the client application, in this JavaScript, basically here, uses the access token to generate this authenticate endpoint. So this is the authenticate with the client application, and it uses this token. Now this token should be only usable once. It should be like something that you use once and you consume, and you can never use it again. Why? Because if you can use it again, and if you can use it with other credentials, this can become a problem, because basically you can exchange this token with an access token and to access the data account, basically. So that's why that's what's up with the first lab. So that's the idea. So let's continue our journey with the second lab. So in this time, for this lab, we want to exploit a server-side request forgery via client registration of OpenID. So we want to register a custom client using the OpenID format protocol, and this somehow will trigger a server-side request forgery. And we're going to use this server-side request forgery to access an internal endpoint. Because remember, when we're talking about SSRF, the idea is that we're going to have our client here, then we're going to have the OAuth server here, and here there is like a security boundary. Now we can interact with the OAuth, but with server-side request forgery, the idea is to use this OAuth as a client to access this 169.254 whatever. So we're gonna use the SSRF in here to force the OAuth to act as a client to send this request. Now, how does it work? Well, here I have the lab. And let me just copy into Chrome here with burp. So if you go into my account here, it says we're not redirecting you to log in with social media. Actually, here I've previously logged in with this. So I think I should just clear out all the cookies. So cookies, delete browsing data, cookies and other site data, all time. Just gonna delete everything. And here I'm just gonna do a logout. So let's do what happens here. Okay, now we have this sign in again. Now at this point, we can put our credential, winner and Peter, right? Winner Peter. I'm gonna say this, and it's gonna say authorize. So at this point here, we have a bunch of requests here. The interesting request at this point is, now in this case here, what do I have? Here I have the sign in, then here I have the post login for sure, and it's gonna say found. I'm gonna say redirect, I'm gonna say authorize this thing, and then I'm gonna say client logo. So here basically I can access the logo of the client, and here I can say continue and stuff like that. Now, if you want to register, like here the idea is that we need to register a client. So the question then becomes, wait, how do we know how to register a client? And here comes some well-known path in the OpenID, basically. So in this case here, we can go into this path. So let's go into .well_known, actually not here, but in the OAuth. So it's not in this server. From the OAuth server, so let's go into OAuth, like not this one, this will be OAuth, okay, this one, for example. So I want to interact with the OAuth host, and I want to go into this path. So it's gonna be .well_known OpenID configuration. I do send. Okay, here it says bad request because I think I have to do slash well-known like this. And look at this, it says 200 OK, and I get this information. Now, how do we know about this path? Well, this path is used to expose the OpenID configuration. You can just search for it, basically. Well-known configuration, it's like this is a well-known path, so there's nothing to guess here. Just when you enumerate OAuth, remember to consider this path. And basically here, let's see something about registration. Registration endpoint. So here we have the registration endpoints, and here we have the OAuth server.net/reg. So that's basically the idea. And so this is how we find the registration path. So at this point, we can actually perform a registration request. Now, how do you do that? Well, first of all, let's create a new request in here. This is gonna be to the endpoint/reg, register. We're gonna change this into a body request. So change request to body. The endpoint is gonna be an application JSON. So the body is gonna be an application JSON, and the body should contain the following things. So here we have to put redirect you. Like if you just put an empty body, let's see what happens. It's gonna say bad request, something went wrong, invalid request, failed to parse the request body. Of course, because to register a client, we need certain data. Now the data we need for sure is the redirect URIs. So redirect URIs, And this is an array of valid endpoints that we can redirect at the end of the process. So here I can say https example.com, basically here. And look at this, it says created. It's gonna be, so like it just needs this thing basically. We have redirect URIs, we have client ID, and we have a bunch of other informations that are related to this client. For example, here there's also the client ID that is used when triggering this. And basically that's the idea. Now, however, to exploit this SSRF, what's the idea? Well, the idea is to understand that actually the attack vector is the image. So remember, previously we saw that the application requested the logo, right? This logo here. This is the client application, by the way. However, the OAuth server, to get this logo, like we can specify the logo during registration by putting a URI, logo URI. And here we can put our malicious endpoint, basically. So the one that they gave us, which is this one. We can put this. And what's the mentality here? Why are we doing this? Well, because the idea is that when the OAuth server will register this client, it's going to want to load the image so that it's going to be able to give it to the final client when we see the social login, right? That's the idea. Now, in this case, when the OAuth server is going to request the image, it's actually going to request this endpoint, which contains sensitive data, and then it's going to allow us, the final client, to access it through this other endpoint. So let's do this. Let's send this request. Look, it says created. It says logo URI in here. And then if I go into this client here and I change this client ID here with the client ID that was given by the registration, which is this one here, I should expect to find something interesting. And look at this, I actually do. Here, I'm reading this file. Now, this file is not the logo for this client. I mean, it is the logo for this client, but it is not an image. It is rather an application JSON. Why? Because the OAuth server during client registration loaded this data. So that's the idea. So to recap, the second lab was not really with the authentication flow itself, it was with the client registration flow. Now the client registration flow we can analyze by going to the well-known OpenID configuration. Here we check the configuration endpoint. We know by the standard that here we can take at least the redirect URIs and the logo URI. And if we put a malicious URL in the logo URI and then we access the specific logo, we get what we need. So submit solution. Here I'm pretty sure we need the secret access key, this one, and we have solved the lab. And how did we figure out about this client logo? This was figured out by following one time the authentication flow. In the authentication flow, at some point, we ask for the logo. This is the logo we see when we perform the login itself. And so basically that is the second lab. Server-side request forgery via OpenID dynamic client registration. And this of course shouldn't happen. Like you shouldn't allow anyone to register OpenID clients. And also when you go and fetch the URI like this, you should put some kind of whitelisting mechanism to like not access arbitrary hosts, otherwise you're vulnerable to server-side request forgery. And by the way, this often happens, I've also seen it in bug bounties, that many times applications have to deal with resources such as images, and instead of having images, they have URLs for images. Now in those cases, if as a client you're able to configure such URL, you might have server-side request forgery unless they put some kind of validation on the kind of URLs that they allow. So that's the second one. Then let's do two more, force OAuth profile linking and OAuth account hijacking via redirect URI. So let's do the third one. So let's access the lab, let's wait and let's go. So let's analyze the lab description. Now this lab gives you the option to attach a social media profile to your account so that you can log in via OAuth instead of using the normal username and password. However, this is insecure. So to solve the lab, we need to use a CSRF attack, so a cross-site request forgery attack, to attach your own social media profile to the admin user's account on a blog and then access the admin panel and delete the Carlos username. Now the admin user will open anything you send from the exploit server and they always have an active session on the blog website. So what's the idea here? The idea is that we have this application, so let's put it into here, into the browser. Let's delete everything here. Let's delete the browser history. So here we have this application. Now in this application, we can perform our, we have this blog, we can do my account. I can either log in with normal credential or with my social media account. And social media profile peter.winner.hotdog. So we have a basic login winner Peter with the application itself, like winner Peter. And here we do a basic login, we give the credential, and we obtain the session cookie. Notice here that there is protection against cross-site request forgery attacks, CSRF. So we cannot perform a CSRF attack on this endpoint. And so that's the idea. Now, if instead do like, and here we can, by the way, okay, we can attach a social profile to our account. Okay, interesting. Now, how does this attachment procedure work? We click on this. Okay, look at this. We have started this OAuth client ID here, and it says OpenID profile email. Okay, OAuth linking. Then we enter the username and the email. This one is of the social profile. So peter.winner and then hotdog. Sign in. So here we have the post login with the credential. Here we have the interaction. Here it's gonna say is requesting access to this thing. So let's actually intercept this. If we do continue, here I'm gonna say confirm. Okay. Here I also want to, by the way, proxy the request, intercept request, and intercept responses. So I want to intercept everything. I do forward. Here is the response found with the OAuth serve. Here is get with this one. And here I have found with this OAuth linking code. So this thing should like link my user account with my social media account. So that both things should be linked. Now, however, if I don't go through with this, but if I copy this link and I drop this request, so I'm dropping the last request, right? I'm dropping the last request. Here, this thing like didn't work anymore, right? So this one didn't work. Now we are into my account here and I can just log out. If I go to exploit server, here at this point now I can craft an exploit. I can make the admin account actually click on this link. How? Well, there are different ways of doing that. I can, for example, create a script that's gonna redirect the user with the document.location. Then I'm gonna put this into the location. And then basically I'm just gonna have an exploit server that, I have an HTML, and then here I have a body. Okay, so I have like this basic POC. I can just serve it. So head body. So in this body, I'm just gonna do this. Okay, it's gonna be text HTML, file exploit. I'm gonna store and I'm gonna deliver the exploit to the victim. So by the way, here I'm gonna remove my webcam. I'm gonna deliver the exploit to the victim. Now, what happens? Let's see the access log. Now in the access log, we can see that the victim here got the exploit, got the malicious payload basically. So got the malicious payload. At this point, what we can do is let's log in with social media. Now we are doing a login with social media with our account. Now if the admin click on the link, he will have connected his account to our social media account. So if we sign in, okay, continue. As you can see here, we got the admin panel and here we can delete the user Carlos and we did complete the lab. So what was the problem in this case? Well, the problem was that this linking, like the link we got at the end of this flow, like let me see again, it was before. So it was like, it was before, let's see, we get this thing, we had this interaction, then we have this confirm, and finally we had this, right? This final redirect here, we had this code to connect our account with the social media, but this code did not really validate what kind of two accounts were we connecting. And so like it did not validate that the account we were connecting was the one that started the flow. So basically we started the flow with one account, then we got this link, and then we use it to connect to another account, which is the admin account. And so basically we force the admin account to use our social media. And by doing this, we are able to authenticate as admin with our social credential. So that's the idea. So this is an authentication bypass. And the attack requires user interaction because we use an exploit server and we send to the malicious, to the victim client, we sent this payload. Now this payload simply triggered a cross-site request. It triggered a cross-site request. And in this cross-site request, we are just linking his account with our social media profile. So of course, this is why it is a type of CSRF, because we are sending a cross-site from a malicious website to the vulnerable website, which is this one. to perform an action. In this case, is the linking action with this endpoint OAuth linking. So that's the third lab. And finally, we can check out the final fourth lab. I mean, here there are two more, but in this case, I'm just gonna stop at 4 because the video is already long as it is. So we can access the lab, we wait a bit for it to spawn, and then we can show how to solve it. So let's go. Now let's read the description. So this is an OAuth account hijacking via redirectory. So now we're gonna mess up with directory. Now this lab uses an OAuth service to allow user to log in. To stall the lab, we want to steal an authorization code associated with the admin user, and then we want to use it to access their account and delete the user Carlos. Now the admin user will open anything you send from the exploit server, and they always have an active session with the OAuth service. So here we have our lab. Here we have our lab. So let's go into my account. Let's redirect here. And here it's gonna say sign in, right? Perfect. Now, notice this thing. When we start this interaction with the OAuth, because now we are talking with the OAuth server, by the way. We are talking with the OAuth server. Now, when we start this interaction, actually, let me clear everything, by the way, here. I want to clear everything. I want to go back to the original websites. So let me clear history here. So this is the original website. Okay, then I go into my account. Then it's gonna start this redirect to the OAuth service, which is where I found this login. Now, look at this. When I started the interaction with the OAuth, I started here in the get parameters with this. Here it says interaction blah 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 because it's the second get, but the first get that was redirected contained a redirect URI here, okay? Contained this redirect URI. What does it mean? Let's do this. Let's copy this URL. Let's copy this URL and let's change this redirect URI to point, for example, to google.com, right? And let's open this kind of instance. Notice that from the point of view of the user, nothing changed here. However, from the point of view of the server, stuff changed because now we're redirecting to Google, yet here it just says found, right? It validates this thing. It does not create problems whatsoever. And this is not good. Now, if we continue, for example, if we put winner and then Peter, and we say continue here, look at this. Now I'm back to Google, like I'm redirected to Google, not to the application itself. And why is this a problem? Well, it is a problem because if we check one of those first requests back to Google, here, look at this. Google will get the authorization code. Now, of course, Google does nothing with this authorization code. However, what if this was not Google? What if this was a malicious client? And this is what we're gonna do. The attack basically will be, we phish the admin, and we phish it by preparing a link with a malicious redirect URI. The admin will click on this link, will trigger the authentication with OAuth, and at the end of the day, we will get the authorization code in a malicious server. So basically, that is the idea. So let's do something. Let's clear all the cookies in the OAuth service and in the normal service here. Let's do this. Back to home lab. Let's clear everything here so that we have no cookies anymore with no server anymore. Perfect. So we are clear. Now, let's go to the exploit server here. Okay. Then we go into my account, but actually we just need to, I believe, let's just get the latest interaction here. This one, we say copy URI. This one contains the thing that we have to maliciously modify it. And the way we do it is we change the redirect URI. And we change this redirect URI basically as follows. We change the redirect URI with the malicious, like for example, in this case, we can also use burst. So let's use collaborator. So I'm gonna copy the collaborator website here. And here I'm gonna say HTTPS. So the redirect URI is gonna be this. It's not gonna be the original one. It's gonna be my malicious website here, my malicious callback server. Everything else seems fine. Of course, we need to wrap this in, for example, an iframe we can do so that the client will click on it, basically, will trigger the interaction like this. I think an image also works fine, by the way, like if you do image source. Anyways, we go into the exploit server, we put this in the body, exploit HTML, we store it, and we deliver this to the victim. Now, when we deliver this to the victim, let's open burp here. Let's deliver this to the victim. So let's see if we get something. Let's pull. Okay, look at this. We have some interaction. And we have this interaction. Look at this. OAuth callback code. Now, this thing was sent by the victim browser. After having done through everything, the OAuth made a redirect to the callback. The callback was our malicious server. We got his authorization code. Now, in this lab, though, let's say that, let's say that I want to see how the authorization code is finally exchanged to obtain the final account session. So now I need to check how to exchange the authorization code. Where is this? So here I have OAuth code, okay. Just like this. Okay, I just have to use this, but with the code that was sent to the collaborator. So this thing, basically. I have to use this thing, and it's gonna give me a session as admin. So this cookie, okay. So now we are winner, but I'm gonna change this. I'm gonna change this, and I'm gonna put the admin cookie that was obtained by stealing the authorization code. Now we are admin, and now we can delete Carlos, and we have solved the lab. So to recap this fourth and final problem, what was it, the vulnerability here? The vulnerability was in the fact that we could put an arbitrary redirect URI. Now why is that dangerous? Because the redirect URI is used at the end of the process to redirect back to the application. If in this redirect URI we put a malicious URL and the client clicks on that flow, authentication flow, at the end it's going to get a redirect to the malicious URL, which will leak the authorization code. Once we have leaked the authorization code, we can just exchange it in order to get the session token. For example, in this case, the way we exchanged was here. OAuth callback code, and this gives us the cookie itself. If here you put the authorization code of the admin, we're going to get the session cookie of the admin. So basically, that is the idea. Now, if you support me on Patreon, you have access to this file, which contains all the detailed explanation, but I've also shown them for everyone. So basically, this is it. I hope the video was fun. I hope you got something out of it. If you're interested in web testing, I've created a full course over web application penetration testing, where I show in detail how to test out the security of a web application with 40 different security issues. And for each issue, we write a full proof of concept. So thank you very much. Go and check out the course, link in the description, and to the next video.